Hi everyone, I'm Divya Srinivasan, and I'd like to give a presentation on what do we mean by clusters and the different types of clustering strategies. I'll go ahead to share my screen to share with you the presentation. Okay. Now, first, let us understand what do we mean by cluster. So similar data points or data objects within a data set, they are grouped to form a cluster. And now all the data points in one cluster will be significantly different from those that are present within another cluster. And how do we get clusters? It's by the process of clustering. Now, it means that where we segregate the data points that are similar in nature or share similar characteristics into one group, thereby forming a cluster, and those that are different to form other groups or different other clusters. And now, when we take a single cluster, we can see that the data objects or the data points in that cluster will share the same characteristics. That's one significant aspect of a cluster. And we call clustering as an exploratory data technique. And this is because every process of clustering will have to explore and examine the data points or data objects within the data set so that the characteristics of those data points can be determined to see in what cluster they can be grouped into, and which is also known as the analysis of multivariate data sets. Now, the techniques in clustering, we have three different and important terminologies, which are the point, space, and distance. Points are nothing but the data points of the data objects, like we discussed earlier, present within the data set, and they should be available and suitable for clustering purposes. Space. Space is nothing but the universal set of data points where the data points within the data set exist. That is called a space. We can have the example of a Euclidean space for that. And distance. Distance is nothing but the value or the measure between any two data points in a data set which belongs to a certain space, and more importantly, they are available for clustering. And some distance measures that are available in the Euclidean space are like the Jacquard, cosine, Hamming, and edit distances. Now, these are the important significant characteristics of distance. And these should definitely be satisfied when distance is going to be computed. The first one goes by all distance values are non-negative in nature, and the distance measure between a data point to itself will be zero. Otherwise, it's going to be anything greater than zero. And the second one is that distance is symmetric in nature. So no matter how the distance is computed between the data points, but when it's computed, it's always going to be symmetric in nature. And the distance measures should satisfy triangle inequality. So for example, say you want to go from, you want to measure the distance between X and Z, and you go directly from X to Z, or you travel from X, Y, and Z. No matter what, is going to be equal, and the bigger one is not going to be lesser than the X to Z computation. Clustering strategies. So we have two main algorithms discussed here, which are the hierarchical or the agglomerative algorithm and the point assignment algorithm. The hierarchical one has the clusters where they're initialized, and these clusters have their own data points, and the clusters are then assigned to be combined based on the closeness attribute. So however close cluster A is with cluster B, they can get combined. And the next step here is that these combinations of clusters will stop when undesirable clusters begin to arise. So what is meant by this is that when the clusters are no longer showing the closeness attribute, this combination stops. That's about the hierarchical one. Moving on to the point assignment algorithm. Here we have Again, similar to the previous algorithm, we have the clusters that are initially analyzed. And again, now the data points within the clusters here are chosen in an arbitrary or random fashion. And every data point is assigned to the most suitable cluster. So once the data points are chosen, they have to be put into a cluster. So the assignment of data point or data objects to clusters are done based on the most suitable manner. And lastly, if any variations are detected, we can have the occasional combining or cluster splitting or removal of any outlier data points. By removal of outlier data points, it means that any data points which are not showing similar characteristics or that have characteristics that are quite farther from the ones that the others have, these are the outlier data points and they should be removed. And lastly, we have our other distinguishing factors for clustering. So the two algorithms that we discussed here. So any of the algorithm can assume either a Euclidean space to work with or can work with a random distance measure. And also any clustering algorithm can decide if the data points within their clusters are small or large. If they're small, they can be residing in the main or the primary memory. And if they're too large, they can stay in the secondary memory. Now let's see a question here. What are the important characteristics in computing distance? So like we saw earlier, we have the three salient characteristics in computing distance, which goes by distance should always be non-negative in nature and can only be zero when it's computed from one data point to itself. Secondly, distance is symmetric in nature, no matter in what order it's computed. And thirdly, distance must satisfy triangle inequality property. And that's all about it. Thank you.